Hello everyone, welcome back to another video from mychemcorner. So before we move into the video, if you're new here, please don't remember to subscribe to the channel and hit the bell icon for further notification. So in today's video, we're going to talk about problems on how to find the formula of a compound. So in the last video, we learned about how to find the number of atoms that belong to a simple cube, to a BCC and FCC. So we are going to use that information to find out the formula of a compound. So let's see how to do that. We'll move into the very first problem. So the question 1 says a cubic unit cell is made up of 3 elements. So we have 3 elements here, X, Y and Z. Now of these 3 elements, atoms of X are present at the corner. So if you're taking a cube or if you're sitting in a room, you can imagine that each corner of the room is occupied by atoms of X. Atoms of Y are at the cube center, just like your body centered. When you're sitting in the room, the center of the room has a atom which is denoted as Y, and atoms of Z at the center of each face. So the room that you're sitting in, each wall, the center of each wall is having a sphere or an atom which is atom of Z. So this way, X are present at the corners of the cube, Y is present at the cube center and Z is present at the center of each face. Keeping these information, you need to find out what is the formula of the compound. So before we move into how to find the formula and all of that, we will have to compare this question to how to find the number of atoms per unit cell, which we did in the previous video. If you haven't watched that video, I'll put that link in the description box. Please do watch it before you solve problems based on this. So now, what have they given in the question? X is present at the corners, Y is present at the cube center and Z is present at the face center. So we are going to solve it individually for each of these atoms. So the first one is number of X atom that's present per unit cell. It is only said that X is present at the corner, which means it is for number of atoms of a simple cube. So here we will take the calculation of a simple cube for X atom. So 8 are present at the corner, and out of that only 1 of it is being shared with 8 of the other cubes. That's why it's written as contribution. When we solve this, it will be 1 atom. This you get from number of atoms per unit cell for a simple primitive unit cell. Now let's look at Y. Y is present at cube center. Now when we talk about cube center, we're talking about a BCC or a body centered cube. So for this, at the cube center, only 1 atom is there and its contribution is only 1 because that particular atom is belonging only to that particular cube. When we solve this, you get only 1 atom here. Now the last one is Z, which is at the face center. So if you're having an atom which is present at face center, then those kind of a unit cell is called as face center unit cell. So we're going to take our calculation for Z from there. We have 6 face center into 1 by 2 contribution, which means 1 of the sphere is shared with the same face of the next sphere. That's why it's written as 1 by 2. This is also there in the previous video that I had taught you all. So kindly go through that, only then move into the problems related to this. So when we solve all of this, we have 1 atom and 3 atoms. Therefore, the ratio here is going to be 1:1:3. So the formula of the compound here is XYZ3. So here, only if you know how to calculate number of atoms per unit cell for a simple cube, for a body centered cube and for a face centered cube, it's easy for you to find out formula for a given compound from basic information given in the question. Now let's move into the second problem. The second problem is a cubic unit cell consists of 2 elements P and Q. So in this case we have only 2 elements. One is P and the other one is Q. Now atoms of P are present both at corners as well as face centers. So here P is present at the corner of the cube and it is present at each face center. So basically P has a face centered arrangement. And Q is present both on the edge center and the body center. So in the edge centers as well as body centers, basically BCC. What is the formula of the compound? So here what is given to us? The atom P is present at the corners and at the face centers, whereas Q is present at edge center, which means we have the edges of the cube, the center of that cube. Center of those edges it is present. So those are edge centers and body center. Now let's calculate for P. P is present at the corner. Now corners meaning it will be 8 corners and 1 by 8 contribution. Plus it is also present at the face center. So how many face centers do we have in a cube? 6 face centers. Out of that each atom is shared with 2 cubes. So that's 1 by 2 contribution. When we add up both, you will get 4 atoms of now P. So here we have taken the first half is for simple cube, the second half is for face center. Let's try to do the same thing for atom Q also. Now for atom Q, the first thing what it says, it is present at the edge center. If you draw a cube and if you count how many edges are there in a cube, we have 12 edges. And when we place the cubes one above the other and beside them, each sphere on one cube is shared with 4 other cubes. So if you imagine yourself sitting in a room, you have one room above yours, one room beside you, and one room, the one beside you, there's one above that. So what happens? There are 4, right? And when there are 4 like this, just like this cube, you have one here, you have one here, and one in below this and one below that. So what happens is, say for example, I want to check this particular line. I have a center sphere at the right in the center of it. Now what happens here is, if I check how many it is shared with, it is shared with this cube, it is shared with this cube, and it is shared with this cube, and it is shared here. So what is the contribution? It is 1 by 4, because one sphere is shared with 4 other cubes. That is for edge center. Now the next one is a simple one. It is for a body center. Obviously one sphere is present at the body center. Its contribution is nothing. It is only belonging to that particular unit cell. So here when we calculate all this, 12 into 1 by 4 will be 3. 1 into 1 will be 1. When we calculate, it is 4. So here the total ratio is 4:4. When we simplify it, we will get 1:1 as the ratio. Therefore, the formula of this compound is PQ. Just a simple one. So for these type of problems, all that you need is, say, either a diagram that you can draw like this, or you can just imagine yourself sitting in a room which is of a cubical shape. You have adjacent rooms and you have rooms above or below, and you're going to imagine the spheres either present at the corner, they're present at the face center, or they're present at the edges of the wall, or they're present at the body center. So it's just all about imagination that will help you solve these problems much easier than mugging up how to solve it. So either a diagram, or imagine yourself sitting in a room which is considered as a cube, and then you go ahead and solve the problem. Then let's solve 2 more questions of the same type. The next one is problem 3. Here a compound AB has an FCC structure. FCC meaning face centered. Now while atom A occupies the corners of the cube, only the corners A is occupying, B are at face center. What is the formula of the compound? Very simple one. We will take the calculation of A of a simple cube and calculation of a B only the face center. Then when you calculate this, you will get what the formula is. It's a very simple question. So let's see first what is given to us in the question. A is at the corners and B will be at the face center. Very simple one. Now, number of atoms per unit cell. Where are these A atoms present? Only at the corners. So you take the calculation of number of atoms per unit cell of a primitive unit cell. So here it will be 8 at the corners and 1 by 8 of contribution, which will be 1 atom. Next, when we see for number of atoms of B, per unit cell. Because B is present at phase center, you take the phase center calculation. We have 6 phases in the cube. Out of that, for each phase, 1 atom is shared among 2 cubes. So here it's 1/2 contribution. When we calculate it, you will get 3 atoms. Now here it's a ratio of 1:3. Therefore, the formula of the compound is going to be AB3. Very simple one. Now let's move into the last one, which is a bit different here. Now in this case, in a cubic type of unit cell of a compound, A atoms are at 1/2 phase. So they are only present at 1/2 of the phase. While B atoms are present at the corner. B atom is easy. I'll help you solve what are the A atoms. Calculate the formula of the compound. So here, when we talk about the given things in the question, A atom are present at 1/2 phase and B are present at the corners of the cube. So now, when you look at this, let's try to solve it step by step. When we talk about 1/2 phases, first let's see how many phases a cube has. So here, the number of phases are 6 in a cube. When we say 1/2 phases, half is the contribution, right? This is the general contribution of an FCC into 6 at the phase center. So here when we talk about this, it is only 3 phases actually, because it's saying 1/2 of the phase. The number of phases are 6 in a cube, of which only 1/2 of this phases are occupied by A. So half of this is nothing but 3. Now, number of atoms at these 3 phases will be 1/2 of contribution into only 3 phases, because it's not present at all phases. It is only present at half of the phases. So 1/2 into 3. When we calculate this, you will get 3/2 atoms of A. Now the next one is atoms at corner is easy. It is for a simple cube. 8 at corners and 1/8 of contribution, that is equal to 1 atom. So in this case, the ratio is 3/2 is to 1. So we will expect the formula of the compound to be A 3/2 B1. But these kind of formulas don't exist. Now when we look at a formula, say for example looking for a magnesium salt, it will be MgCO3, MgSO4, calcium carbonate will be CaCO3 or CaSO4 or CaCl2. So what happens? There is a whole number in the formula. So same way we have to do here. When we simplify this, you add up the ratios. Right? When you simplify this, your formula is called, so you multiply the ratios. When you have this, this will be 3A3B2. That is the formula of the compound. So this way, you will be able to solve or find the formula of a compound, provided you know how to calculate number of atoms of unit cell for a primitive unit cell, for an FCC or for a BCC. Now apart from this, there's a lot more of diagrammatic imagination, or your own imagination of you sitting in a room which is considered to be a cube. The corners of the room will have a sphere. The faces of the walls will also have a sphere in the center for an FCC, and right in the center of the room you have a sphere that will be BCC. So this way, if you're able to at least imagine, then solving such questions will be easier. So if you're going through this video, and if you have not gone through the previous one, please ensure you click out of this video. First watch the previous explanation video, which I'll be putting up in the description box. Please learn that, only then move on to these problems given here. So meanwhile, if you have any other queries or anything, you can please write down an email to me that's given in the description box, and I'll be answering to you. Or if you have any other suggestions, please put it up in the comment box and I will take care of it. Thank you so much for watching. Stay tuned for the next video.